Assalamualaikum everyone. My name is HAKIM NAIM, and today I will be presenting the binary compounds of the group 14 elements. So let's get started. Okay, for the first one, what is the binary compound? A binary compound is a substance composed of exactly two different elements, which are substances that cannot be simplified further by the chemical means. So what elements are in the group 14? So there consists of 5 elements, which is carbon, silicon, germanium, tin, and lead. And going down the group, the atomic size increase, and the electronegativity for the group 14 will be decreased, as well as the ionization energy decrease as well. As you can see in the graph that we already created right here, we can see that the melting point and the boiling point of the group 14 decreases each time. So what are the uses of group 14 elements? So germanium, which commonly used as a material for construction of transistor, tin to plate the steel for use in tin cans, and lead for the plumbing and in solder. Plus the bronze is the alloy of tin and copper. So electronic configuration of group 14 elements. The group 14 elements have a general electronic configuration of Ns2, Np2. These elements have 2 electrons in the outermost p orbital. And the electronic configuration of these elements is already shown in the table below, which consists of carbon, silicon, germanium, tin, and lead, which is the group 40 elements. An animal's behavior of carbon. So anomalous behavior of the carbon, it has a small size, high electronegativity, high ionization enthalpy, absence of d orbital in the valence shell. So the compounds formed by the group 14. So for the first one is hydrides of group 14. All the elements of group 14 forms hydride. Carbon forms hydride intensively due to their ability to catenate. The hydride of carbon are categorized as below, which is the alkane, alkenes, alkynes, aromatic compounds. Silicon forms hydride having the general formula, which is this SiN, H2N plus 2, and are called as silanes. And the germanium forms hydrides of the form GeN, H2N plus 2, where N mass is equal to 5, and are called as the germans. For the tin forms SnH4 and are called as stannate. It is much less stable than the other hydrides. So for the next one, which is the halides of group 40. They are formed tetrahalides of the form MS4. The central atoms is sp3, hybridized and assumes a tetrahedral shape. So for the note, elements below C have empty d orbitals, with which they can exhibit back bonding with the halogens. And the carbon do not form dihalides. The dihalides are sp2, hybridized, and have band shape. So for the next one, which is outside of group 14. Group 14 elements form outsides of the type MO and MO2. Lead also form an outside PB304, which is a mix of outside of PBO and PBO2. Amount of monoxide CO is neutral, GEO is basic, while SNO and PBO are amphoteric. In CO2, C is sp hybridized. It is different from SiO2, in which Si is sp3 hybridized. In SiO2, HO atom is bonded to 2 Si bonds. This gives rise to a three-dimensional structure for SiO2, and this also attests to the high melting point of SiO2. And among of dioxides, the acidic character decreases down the group. CO2 is the most acidic, and PbO2 is being the most basic among the diodes. So for the reaction for hydrides, there are consists of two, which is tetrahydrides and hexahydrides. So let's take a look for each one of them. So for the tetrahydride, adds H4. The methane gas, which is the carbon tetrahydride, reacts with oxygen by combustion. As you can see, for the reaction, CH4 plus 2O2 will become CO2 plus 2H2O. For the hexahydrides, H2 adds 2H6. The ethane dicarbon hexahydride reacts with oxygen by combustion as well. For the reaction, 2C2H2 plus 7O2, it will become 4CO2 plus 6H2O. For the change in the oxidation number of carbon when ethane is burned in acid of oxygen is plus 7. And for extra information, there are also the reaction of the hexahydrides osmium complex with the aldehydes, as you can see in the picture on the right side, right here. And also for the reaction for the silicides, Mg2Si plus 4HCl, it will become SiH4 plus 2MgCl2. Okay, the reaction of magnesium silicides with hydrochloric acid created a popping explosive. The silane ignites spontaneously on contact with air in an explosive exothermic, which is the heat producing reaction. Okay, as well as for the next reaction, which is the 2Mg plus Si, it will become Mg2Si. This reaction proceeds exothermically, even explosively, and it's quite dangerous for us to test it out. Okay, for the next one, which is carbides of carbon. So for the first reaction, which is a 2B2O3 plus 7C, it will become B4C plus 6CO. So for the reaction of carbon of boric anhydride on electric furnace, produce boron carbide, which also called as norbide, and the norbide are usually used as a shielding for radiation. For the next one, which is SiO2 plus 3C, it will become SiC plus 2CO. The reaction of carbon with silica on the electric furnace produce silicon carbide, which is also known as carborundum. So For the next one, which is SiC plus 2 NaOH plus O2, it will become Na2SiO3 plus CO2. For this reaction, the sodium metasilicate is commonly called as a water glass, which is the Na2SiO3 that I told you before. And for the next one, which is the reaction between sodium metasilicate, which is Na2SiO3 plus 2HCl, it will become H2SiO3 and 2NaCl. The reaction produced is metasilicic acid, which is the silica gel that is very good at solvent. Okay, for the next one, which is the highlight of carbon, CH plus 2HO, it will become CO plus 4HS. The reaction of carbon tetrachloride with sodium is highly exogenic. For the next one, which is CCl plus Na plus 4Na, it will become 4NaCl plus C. Okay, for this reaction can occur with explosive violent with CCl4 and other polyhalocarbons. Okay, for the last one, which is the oxide of carbon, the reduction of metal oxides in a blast furnace and the shift reaction for the production of H2. For the reaction, CO plus H2O will become CO2 plus H2. But this is not a complete reaction. It only occurred half of it, or maybe less produced. Okay, for the next one, the conversion of carbon monoxide to acetic acid and aldehydes. CO plus OH will become HCO2 minus. Okay, similarly, the reaction with methoxide ions CH03 and CH3O minus yields the acetate ion, which is the CH3 CO2 minus, as you can see on the right side of this slide. So that was the end for our presentation. I would like to say thank you for lending your ears, and I will see you guys again. Thank you.